We're continuing this chapter with the study of eclipses. Um, in short, the definition of eclipse is when third body comes in between the two and blocks or obscure the view of the object behind it. That's eclipse. In astronomical events, or in terms of the astronomy, when either the sun is blocked by the moon or the Earth's shadow, is casted on the moon because Earth comes in between sun and moon. Those are solar eclipse, lunar eclipse. We'll look at the details in a minute. When you look at the planets and sun, between Earth and sun, there is Mercury, Venus, and every now and then moon comes in the path as well. So there is a chance of at least 4 eclipses to occur. However, the moon, as the Mercury and the Venus, comes in between the same line of sight. This is important. All the objects must be in one collinear line to obscure the view of the object behind. So it doesn't happen every time, but once, sometimes in a century, the planets like Mercury and Venus can come in between Earth and Sun. We don't call these eclipses; these are more of a transit. We don't even see it by naked eye. This is Mercury transit. That happened in 2016, and next won't happen until 2032. So that after 16 years, again these 3 objects will come along the same line of sight. Here it's very hard to see. This was viewed from a telescope, and that telescope image was projected on a screen, and that's how this picture was taken. Here, this is the Venus transit observed in June 5 and 6, 2012. I don't know where you were. I was here at UTA. I was working on my PhD, and we set up a telescope outside the planetarium out there, and I took this picture of the Venus transit. And again, these are not viewed by naked eye, and these don't happen every month or every year like solar eclipse and lunar eclipse. Because of their size and distance and the inclination of the orbits, they are not collinear that often. For example, this Venus transit, it won't happen. You have to wait almost 100 years to see another Venus transit. 2117. I don't know if I will be alive. So I was lucky. I saw Venus transit once in my lifetime. An actual planet passing through this star. And these are so small, there's no significant effect on the Earth. We don't see any major changes as these planets transit. But in case of moon, right, when moon comes in between Earth and Sun, that transit, which we call eclipse, solar eclipse, is significant because that blocks almost 100% of the sunlight, at least for a few minutes. And even it can be a hot August day in Texas, and when moon comes in between and blocks all the light, all of a sudden in that region it can get cold. There are certain other changes that we'll discuss in a minute, and the reason is that uh, for a solar eclipse, there's one pretty coincidence. Uh, the sun and moon, they are very, similar in the size, at least the apparent size, how they look in the sky. You can cover both of them by your thumb. And the reason is sun is 400 times larger in diameter than the moon, 400 times larger, and at the same time it is 400 times farther away. So that makes it look both of the disk of the sun and moon same. They're both angular resolution is half a degree. And here is a quick geometry. This is the Earth, its tilt, its rotation axis, 23.44 degrees to the vertical line. And we also call that Earth obliquity. That's the Earth's rotation axis. And this line here is the ecliptic plane between Sun, Earth. And in this ecliptic plane, the Earth revolves around the Sun, but the plane of the Moon is at some angle, about 5 degrees. So this is the lunar orbit plane, and so this is the plane of the Earth, horizontal. With respect to that horizontal 5 degrees, the Moon orbits like this. This here, so this is the orbital plane of the Moon, and so that's the reason that we don't see eclipse every month. Otherwise, the Moon goes around the Earth every month, and so Sun is at that wall. Here is the Earth, and if Moon goes around like this every month, the Moon should obscure the light from the Sun, but it does not. Because of that 5-degree plane, the eclipse don't happen every month. But when does it happen? Or how does it happen? That's because this plane here is not static. It kind of oscillates because Moon has eccentricity. That eccentric orbit kind of oscillates. So the plane oscillates, and once, twice a year, these two planes, the ecliptic plane and the lunar orbit plane, they align in a way that the Sun, Earth, and Moon lie in the same line, and that's when the Moon eclipses the Sun, and we call that the solar eclipse. Here, again, a diagrammatical explanation. Here's the Sun, quite enlarged to make it simple. Of course, this distance is much larger. It's not to scale. And so this is the Moon, and the Moon's shadow lies behind it, and there are two types of shadow. One, the umbra, and the other is penumbra. The dark region here, where in this region where all of the sun is blocked. Sun and star, same thing. So I've been using interchangeably. Sun is a star. So this starlight here, or the sunlight, is completely blocked. That's the darkest region. That's where we see the total eclipse, and that region is called penumbra. And the lighter region here, these are called, that's umbra. 2 and 3 regions are penumbra, and from these two regions, it's partially blocked. The sunlight is partially blocked. So from these two regions, we see partial solar eclipse. And here, if we are, when Earth is right here, or the shadow falls on the Earth's surface and you are on that specific surface or area or region, all of the sun is blocked. That's where we see the total solar eclipse. And when it's on the penumbra region, we see partial solar eclipse. And if the distance is farther out, around here, because the orbit is ecliptic or ellipse, that distance can change between the Earth and Moon. And so if Earth is around here, from that point, the size of the sun can be bigger, and so the whole moon is within the sun, and we call this as the annular eclipse. You can take a tip of a pencil or any object. When this object is a little farther out, a very small portion of this room is blocked. As I bring it closer to my eye, like right here, everything is blocked. So that distance affects how much of the sunlight is blocked. And again, the geometry. So here, this is the moon orbit. This sunlight falls on the on the moon, and that moon shadow is casted on the Earth. And this moon's shadow sweeps eastward because of the rotation of the Earth towards east at about 1500 kilometers per hour. And again, because of the size, the moon is the smallest object here. The shadow, the region of total eclipse, that is very small. Yet when you look at the surface, that covers pretty wide area. I would say maybe bigger than whole Dallas-Fort Worth region. And as Earth rotates, as moon rotates, that region of total eclipse kind of move within the surface of the Earth. And during eclipse time, you'll see that map where total eclipse can be visible. And here's the actual image taken by some telescope or a professional photographer. About an hour after the eclipse begin. If you remember 2012 event, 2017 event, sorry. The sun, it's all normal. Then moon starts to just enter that region, and it's like a half-eaten cookie. Then it slowly moves in, and about an hour later, the whole of the sunlight is blocked. It gets cold. It gets dark. Even animals behave. I haven't heard, but they say chickens may go to roost. Some animals and people may get disoriented, and it just becomes dark. It feels different. That's what I mean. If you have not, experienced solar eclipse, it's happening in 2024 in Texas, and so we have 2 more years. I know most of you will be graduated and gone, long gone, but wherever you are, I highly recommend to have that experience, to have that feeling. Okay. And during that totality, it gets dark, and even the planets that are never visible during the daytime, the stars that are never visible during the sunlight hours are visible. You know Einstein and all these crazy theories that how gravity bends light. That was tested during the total solar eclipse. The sun has enormous gravitational field that when light travels, when light moves, by its surface, that gravity bends the light, and so the light coming from distant stars were seen to bend towards the earth. And this observation was done in 1919 in Brazil, the total solar eclipse, that proved the Einstein's general theory of relativity that he published in 1915, and that's when he became a real physics science hero. And again, that his theories were tested during the solar eclipse. Yes, sorry.
Where in Texas will we be able to view that?
I am not exactly sure right now. It's still 2 years away. But if I dig hard enough, I may be able to find it. I'll let you know and I'll post it.
Okay.
And you're right. Texas is so big. It's you may have to travel 1 hour, 2 hours to get in the actual totality zone. And we're lucky here at UTA in 2017. We could see from here. And again, depending on the location, catching that total solar eclipse, the totality, it only lasts about 10 to 12 minutes because how fast the Earth is rotating and Moon is rotating around the Earth. And but for that 10 to 12 minutes, it's worth a few hours of travel. And as you can see, when sun is completely blocked by the moon, the corona, the atmosphere of the sun, is visible like this around as seen. This is not the sun, but the sun's atmosphere, the corona, outer layer of atmosphere. And a lot of physics, scientific research are carried out during this event. Because usually sunlight is so bright, it does not allow to distinctly image or measure this sun's corona. But now majority of the light is blocked. It's easy to do to measure these lights from corona and study about the sun's atmosphere. And similar phenomena, lunar eclipse, it's just now the Earth is in between because the Earth's shadow falls on the moon, and since Earth is much bigger than the moon, the lunar eclipse lasts much longer. Here in going from A through C, and this happens during the full moon time. And when they are all collinear, and this length here is 1.4 million kilometers. Moon's distance is 384,000 kilometers, and so the totality can cover almost 3 full moons lying together, stacked together sideways. And so for that reason, the lunar eclipse can last as long as 1 hour and 40 minutes, total lunar eclipse. And it's visible from much part of the world where full moon is visible. And the safety for solar eclipse, we need safety glasses. because of all the harmful radiation that can damage the eyes. We have to have safety glasses to watch solar eclipse, but we don't need to watch the lunar eclipse. It's like watching a full moon shadow. We're just looking at the reflected light from the moon's surface, so we don't need any safety glasses. This is 2017, August 21. And this is in 2017. So even from Texas, as you see, I had a lot of friends travel to these exact location here. That's where you see that 1 to 2 minutes, maximum 10 minutes of totality. Around here it was partial eclipse. I think this was the most eclipsed time here. Again, this is a cell phone picture. I just put my safety glasses in my camera, and I took that photo. But there are, of course, better images that I'll show you in a minute. So next one is April 8, 2024, visible through Texas to Maine region. So I think it's going this way in 2024. May 16, 2022, in a couple months, you'll be able to see the total lunar eclipse. And I will give you more details, time and location. But usually location you can see from almost everywhere. So location is not important. Hopefully it will not be cloudy. That's the main, risk. When even you travel to any of these locations, and if it's cloudy, it's all time and money wasted. These are the professional pictures. This is the totality during 2017 solar eclipse. You see these sun's corona, and even you see these little bands here. These are magnetic field line coming out of the sun, and the corona is full of plasma. Plasma is charged particles, and those charged particles, when they enter the magnetic field, they spiral into the field and move outward, and these are magnetic field lines, or the magnetic field lines directing the charged particles away from the sun. And this is the lunar eclipse in January 31, 2021, as observed from California. And the lunar eclipse during the totality does look reddish. Okay, the moon surface is not this red. The total lunar eclipse, this looks reddish because of the refraction of the Earth's atmosphere, or refraction of the sunlight by the Earth's atmosphere. Because Earth is in between, it's the shadow that falls on the moon. But as the sunlight enters the Earth's atmosphere, these light bend. Refraction is the property of light as it bends, going from one medium to the other medium. So from vacuum, when it enters the Earth's atmosphere, which is denser, it bends, and that refracted light rays from the atmosphere kind of covers that darker shadow regions, and we're seeing this reddish region within the Earth's atmospheric region.